Hello and welcome everyone to the 5G Factor. And today I will be focusing on the major 5G ecosystem developments that have caught my eye. Specifically, I'll be reviewing the key takeaways from Mobile World Congress 2024, recently completed, in the area of RAN, and specifically Open RAN. Now, we also are aware that AI has been a hot topic, so this will definitely be interweaved in my perspective. And in fact, we can call Mobile World Congress AI World Congress because of the preponderance of AI's presence at the event. And we'll naturally break that out more. So to really kick it off, I will start in terms of what was really important that was related to the hot topic of Cloud RAN technology. Now, from my view, the technological innovations that were featured in Ericsson's Cloud RAN portfolio is aiding the communication service providers, or CSPs, to fulfill their need for increased capacity and exponential increases in data traffic. That is, specifically AI workloads come to mind. And this includes solutions that make the best use of the available resources, that is essentially continuing to do more with less. Now, with that in mind, Ericsson has long been focused on energy efficiency and is a core element of the company's overall strategy. I think this has definitely come out in terms of their stated sustainability objectives, as well as ESG-related corporate statements. And this is where I think Ericsson's power comes from and how it can be better manage our fundamental topics in value chain discussions around sustainability, as well as the fact that the CSPs themselves are committed to meeting their own sustainability goals, as well as advancing ESG capabilities. Now, as a result, these developments are being driven by concrete goals, and that is, I think, specific in terms of Ericsson's strategic objective to be net zero and cross its entire value chain by 2040. So this is ambitious, and it's also, I think, aggressive. And basically, the first major milestone will be to reduce supply chain and portfolio and use emissions by 50% by 2030. So that's only 6 short years from now. So this is really having the clock running. This is something we can point to specifically, is how is Ericsson really executing on its not only its sustainability goals, but how it's impacting the ecosystem, especially working with partners and customers such as CSPs in advancing these goals. And as also be net zero in the company's own operations at the same time. And so this is related to scope 1, scope 2, scope 3 objectives. And I think it's very important that Ericsson is really tying it to their own operations in terms of reducing overall emissions across their value chain. Now, I believe that the key to reaching these goals, which are shared by many of Ericsson's CSP customers, is embracing innovation, again, to do more with less. And now this requires more capacity with less energy consumption and better performance using lighter infrastructure. Featuring a number of new additions and improvements at the show is Ericsson's Cloud RAN portfolio, which has taken a step toward high-impact sustainability with built-in performance gains and, quite simply, lower embodied carbon emissions. And as foregrounding, for most mobile networks, over 80% of the energy is consumed in the radio access network itself, and the remainder is in the core network, support systems, and associated cloud infrastructure. So fundamentally, the spotlight is on the RAN portion of the network, since it's consuming about 80%. And so no matter how the CSP is going to approach making its own sustainability goals, RAN is going to be the determinant factor. It will be basically the pivot as to how the rest of the network will be able to, again, support these initiatives. Now, as a result, we are seeing a more relentless focus across the industry on how the radios can be optimized for performance, energy usage, and again, those carbon emissions. And so as a result, what Ericsson is doing with its newest radios is really advancing the threshold for energy efficiency. Specifically, Ericsson's now offering 39% energy savings compared to previous hardware generations. And this is also related in their sustainability and corporate responsibility report from 2022. And naturally, we'll be looking for an update later this year in relation to 2023, and also naturally looking at progress during the course of this year. Furthermore, Ericsson's energy saving software, I believe, can also play a key role in achieving these substantial additional energy savings. Also related to Cloud RAN is the Cloud RAN Distributed Unit, or DU, or VDU, which offers another opportunity to, I believe, improve energy efficiency. Now, I think it's important to note that the approach here is to leverage both the hardware and the software capabilities to reduce energy consumption even more, while maintaining, again, improved network performance. I see this being achieved by balancing the leveraging of commercial off-the-shelf or COTS hardware with the cloud computing platform and innovative algorithm designs to, again, make sure these energy savings are across both platforms as well as generations. As such, the cadence of the generational evolution of the compute CPU is much faster, and thus enables it to catch up and keep pace with purpose-built hardware. Now, as the technology evolves, I expect a possible trajectory that would see capabilities double from generation to generation, all the while maintaining the same energy consumption. So this is something that is very fast moving. It's dynamic. We have to keep a close eye on it. So while there can be advances in the hardware as well as the complementary software in terms of energy efficiency, we also have to look at the overall picture as well. Is, for example, the improvements in RAN networks not being offset by other parts of the network. Also, even with these advances, with AI in mind, are the AI workloads quite simply going to outrun these advances in energy efficiency? Well, stay tuned. I'm going to address this more. I also see that Ericsson is working closely within the Cloud RAN ecosystem in a variety of software and hardware partners such as Intel and AMD in terms of the CPU capabilities, as well as Red Hat for container as a service or CAS capabilities, plus HPE and Dell naturally in terms of the server capabilities. And all this has to come together to ultimately bring new Cloud RAN innovations to the market. And this is where I see Ericsson heading increasingly. Because on the hardware front, Ericsson is engaged in these collaborations to improve the efficiency of hardware by offering a choice of energy efficient servers and accelerators. This enables the ecosystem to take advantage of the larger cloud computing ecosystem itself, as well as applying Ericsson's software to the most power efficient compute platforms that are determined by the CSPs, as well as other players in the market. As such, with new hardware generations such as the Intel 4th generation Xeon Enhanced Edge, Ericsson, I believe, is managing a significantly higher capacity using the same energy consumption based on the initial setups. And also, the company's working on similar projects with AMD. And also, I think it's important to note that Intel has recently announced its 5th gen Xeon processors. So this will be coming to a 5G network coming near you. But also, I think it's going to continue this chain of innovation and diversity in the industry that will further improve those energy efficiencies. For instance, this is underscored that during the show that Ericsson and AT&T completed a Cloud RAN call as a milestone for deploying Open RAN. And AT&T now has commercial traffic flowing on Cloud RAN sites, the first ones of which are located south of Dallas, Texas. Now, the configuration used here for the Cloud RAN has been deployed in the AT&T network, and third-party vendors will be able to use this configuration for Open RAN also in the future. And I think this is an important takeaway because it spotlights that there is definitely an Open RAN dimension to the AT&T deployment. And when they first came out the win in December of 23, there was a good deal of criticism about the openness of the Ericsson AT&T collaboration. And well, here we are. Clearly, it's part of the roadmap. And other vendors such as Fujitsu on the radio side can attest the fact that, yes, the AT&T Ericsson Open RAN implementation is genuinely open and also incorporating third parties. And we'll see more of that, I believe, in 2024. Now, with that, let's turn to some of the other, I think, major announcements that occurred at the show. Specifically, let's turn to Nokia, which unveiled that its Cloud RAN solution will be available commercially during 2024, following the successful completion of multiple trials across the planet with hardware vendors, web scale companies, and chipset manufacturers. Nokia's anyRAN approach can enable a fast transition to hybrid environments of Cloud RAN and also purpose-built RAN that can ensure a consistent performance and interoperability with common software and inline acceleration architecture. This, I think, is aligning with the fact that Nokia has announced the launch of anyRAN for enterprise in partnership with Cisco, HPE, and Microsoft that will see the companies offer private wireless solutions to enterprise customers. Now, from my view, I think Nokia has definitely established a clear presence in the private 5G or the private wireless market overall. I believe it is the market leader here. But I think what is also important is that enterprises are really warming up to 5G as part of their overall corporate strategy, that we're going to see in 2024 what can be broken out as enterprise 5G really take off, and private 5G will naturally be a key part of this. Also, it's important to note that Nokia has completed global trials with its ecosystem of partners to enable its customers to build what can be characterized as future-ready Cloud RAN networks that remove some of the intricacy and ensure that openness and flexibility that is going to be, well, essential for the operators to really advance Cloud RAN as well as Open RAN implementations. I find that this then means mobile operators and the enterprises can choose any server as well as cloud environment, including that CaaS layer, the container as a service layer, with higher layer processing architectures and associated server hardware providers without dreaded supplier lock-in. So this is really having momentum, and it's really putting the openness in the Open RAN dimension of Cloud RAN implementations, as well as the broader open 5G ecosystem. Underpinning this, I believe, is Nokia's high-performance, energy-efficient inline acceleration architecture that integrates with all the key cloud or server infrastructures that are in the market. And as such, Nokia has successfully performed 5G data calls, that is layer 3 calls, in multi-vendor setups. Plus, Nokia's flexible anyRAN approach can support any purpose-built hybrid or Cloud RAN environment, thus helping customers to get their Cloud RAN services up and running with much more swiftness. And so this is, I think, another key aspect here is that, okay, I think, we've gotten past a lot of the tire kicking. We're already seeing earnest implementations. We're already seeing that Open RAN already has market share within the overall RAN market. Granted, it's in the single figures, but I anticipate that will become double figures by next year because of all the things that I'm touching on here that were basically either announced at the show or showing a more tangible progress. As a result, Nokia's anyRAN for enterprise, it can offer more choice and flexibility through the collaboration with the system integrators as well as the cloud or solution providers, alongside Nokia's AirScale radio access portfolio that can meet their specific needs. And so there's really no way around it. Every organization out there, virtually every enterprise, is going to have specific requirements as to how they're going to make 5G more integral to, say, their WAN implementations. And also, basically their hybrid workforce organization. So this is something that clearly I think will benefit by Nokia pre-packaging these solutions together along with the mobile operators and enterprises to basically accelerate naturally the deployment, because we know the interoperability is built in, that's been pre-tested. And this, I think, will be a confidence booster in terms of enterprises warming up all the more during 2024. Now, next, I'd like to also provide a level set on, okay, we're seeing, the Cloud RAN suppliers demonstrating energy efficiency gains that are keeping pace with the hardware and basically assuring that, okay, the RAN itself can improve energy efficiency over the prior generation RAN offering. Now, what I think is also important to keep an eye on during the AI era particularly is that the energy efficiency progress in Cloud RAN needs to align with the energy consumption of the overall wireless systems and the digital ecosystem. Fundamentally, the more we see wireless electronic devices being used and adopted and deployed, the more energy that will be consumed. And quite simply, 5G can exponentially increase the energy usage just from the 5G capabilities themselves. And I already touched on that. Now, to drill down more, the small cell forum has been predicting that the installed base of small cells will reach $70.2 million. 70.2 million by 2025, and that's just next year. And that the total installed base of 5G or multi-mode small cells in 2025 will be 13.1 million. So this is quite simply a vast expansion of just the small cell components that are required for 5G deployments. And clearly that is going to raise the temperature, so to speak, for more energy consumption. And this is still independent, mind everybody, that this is independent of the AI workloads. Now, what I think is important is that the 5G base station is generally expected to consume about 3 times as much power as a 4G base station. And this has, I think, been something of a deterrent, like why haven't the operators been more proactive with implementing 5G standalone after investing heavily in the spectrum that's required for 5G, as well as starting off, with what can be characterized as the no-brainer 5G non-standalone implementations, which is basically combining existing 4G radios with 5G capabilities, or basically using existing LTE core capabilities with the new 5G radios. And that simply did allow for quicker deployments, but the near-term trade-off was that you're not getting the full benefits of a 5G network. But now with 5G standalone, I think we're going to see more of that because quite simply the ecosystem is getting better at improving the energy efficiency, at least of the RAN aspect, as well as other parts of the 5G network. I think it's also important to note that in a recent 2022 review by the University of Sussex Business School, which was titled The Energy Use Implications of 5G, reviewing whole network operational energy, embodied energy, and indirect effects, basically pointed out that 5G is not really currently backed up in terms of strong publicly available sustainability information. Now that could be debated, but I think what's important here is that what we're seeing with Ericsson and key partners such as AT&T, Intel, AMD, Red Hat, HPE, and Dell, that this is changing. And likewise, when it comes to Nokia, working with the Ciscos of the world to improve basically the metrics here. Now, in addition, there is a 2023 study that studied energy use from 5G networks in China. And basically that study stated that it revealed a carbon efficiency trap of 5G mobile networks, leading to additional carbon emissions of 23.82 metric tons, give or take only 1.07 metric tons in China itself. Now, what they identified is that this was being caused by the spatio-temporal misalignment, how's that for a phrase of the day, between cellular traffic and energy consumption in mobile networks. Now, the publication does present an energy-saving method in order to pave the way towards more sustainable and energy-efficient telecommunication infrastructures. Overall, the reality is that current 5G networks are increasing carbon emissions. And while methods exist or are in development to address the issue, they are not fully implemented, nor are regulatory measures ensuring that the networks are adequately efficient. All right, now this is also invoking the regulatory aspects. Now, in places like China, that can become accelerated in terms of how the administrative state there can really prioritize it. But I think outside of China, it's going to be increasingly important, I think, for the 5G networks to demonstrate these tangible advances and benefits. It's not just about the RAN part of the network or the Cloud RAN part of the network, but also the overall 5G network, as well as the overall 5G ecosystem. And the good news out of this, the silver lining, is already that report from China is demonstrating that there are a lot of new capabilities that are allowing for this to occur, as well as the progress we saw out of the announcements at Mobile World Congress 2024. So it's going to be a balancing act. There's going to be a bit of a foot race aspect here is, can advances in 5G RAN efficiencies keep pace with the demands of the network, especially when it comes to AI workloads. In fact, Ericsson's Breaking the Energy Curve report estimated that the power consumption costs of the world's cellular networks will be more than the previously estimated at $25 billion. And as such, CSP should brace for higher costs when it comes to the energy dimension. I've already touched on how this has impacted, say, the time frame for 5G standalone deployments. So simply stated, 5G, of course, is going to be here for quite some time, and that the expansion of this connectivity will continue to benefit overall society, but also we need energy conscious, future-proof portfolios that will make a difference. And so naturally, I will be keeping a close eye on this throughout the course of 2024, as well as, what else are the major suppliers coming up with to make a difference here. And so we'll see how this plays out. But I think there's enough encouraging progress that it can be accomplished, at least the tangible progress being demonstrated in 2024 and beyond. That's where we're going to really see, the proof in the pudding. That is, can Ericsson, for example, meet its own, net zero objectives? Now, with that in mind, there are also other important announcements that came out at the show. So in terms of RAN, so let's turn to Mavenir. And as we know, Mavenir is a cloud native network infrastructure provider. And what they announced is the availability of its open vRAN solution powered by 4th gen Intel Xeon scalable processors, which I already touched on, but it also in combination with Intel vRAN Boost. And what this is, it's designed to, again, deliver a cloud native, high performance and energy efficient solution for those latency sensitive and compute intensive mobile network applications. And so I have emphasized AI a great deal, but there's certainly plenty of other applications out there that are compute intensive. That includes, for example, video applications, as well as, say, AR, VR, XR type applications, which will become increasingly part of the mix. I believe so, at least when it comes to, for example, enterprises. 5G enterprises are going to be more prevalent. The momentum will pick up there because, for example, when it comes to training, I see digital twins as well as AR, XR playing a direct role. And so this is something that I think is going to fuel demand for more 5G enterprise, as well as that balancing of can the bandwidth, can the performance keep pace with energy efficiency demands. And so as such, from my view, Mavenir's suite of performance, functionality, and integrated AI and ML application for 5G networks, as well as existing 4G networks, will enable, I think, Mavenir to build a close and long-standing collaboration with Intel and the adoption of Intel's processors that can enable the development of more efficient and cost-effective RANs. Now, these optimizations are being achieved through the availability of more processing power with higher capacity that can result in the reduction in number of cores or servers needed per cell site. And I think that's something that was a common theme is, again, energy optimization by being able to dial back the cores that aren't needed during, say, low data periods, during parts of the day or parts of the night where there's not so much traffic, and thus the power consumption can closely correlate with what is the actual demand out there, and thus, more energy savings. And naturally, I'll be talking about that more during upcoming 5G factors. But that is in place. That is something that we're seeing from the other RAN suppliers, such as Samsung, that is really being able to turn up, or turn down elastically the cores that are needed for the actual traffic on the mobile network, particularly 5G networks. Now, Mavenir's Open vRAN solution is comprised of this, virtual distributed unit, or VDU, and centralized unit, or VCU, supporting the mobile network generations 2G, 4G, and 5G, and providing a complete baseband unit functionality. As such, that solution is cloud native, again, and easily deployable on the Intel architecture across private, hybrid, or public clouds. I just wanted to bring that to the forefront. It's one thing to be cloud native, but it's also important that it has that flexibility built in. It has to be able to run on a public cloud, a hybrid cloud, which I think will be very common, as well as private clouds. Basically, it will be according to the customer's needs. So certainly when it comes to the CSPs, they need that flexibility to address a wider range of customer demands. But also when it comes to the enterprises themselves, we know that they're going to require that type of flexibility. And with the Mavenir VDU incorporating Intel's FlexRAN reference software, this can, again, utilize modular virtualized control functions across well-defined interfaces that allow flexible and programmable control of the layer 1 wireless infrastructure. And so I think that's going to be a difference maker. Again, what the FlexRAN is bringing to the table is that programmable flexibility, that layer 1 capability that is going to basically enable the other layers to have even more flexibility in many scenarios. And so with that, that is what I believe are some of the key takeaways from Mobile World Congress, or AI World Congress 2024, in terms of the RAN segment itself. And so thank you everyone for joining, and to our viewing audience and our listening audience, as always, thank you for spending time, and we look forward to seeing you again next time. Don't forget to bookmark us. And with that, happy 5G day, everyone.